want to make sure that there's no doubt about this. I want everybody to be clear about how to deal with these kinds of numbers, because we're going to have a lab that comes up. If you have a substance and you're trying to figure out how much mass a liquid material is, you could take that liquid material, set it aside for a minute, but if you take an empty vessel like a beaker, you can put it onto an electronic balance and find out what its mass is. And if that's the mass of the empty beaker, that's great. Let's just say that the empty beaker is got a mass of 80 grams. Then you take your fluid sample, your liquid, and you pour it into your beaker. Now your beaker is partially filled, and you put that onto your electronic balance instead. And now we say that the mass of the full beaker is equal to 120 grams. And the question is, how do I figure out what the mass of the liquid is? We say the mass of the liquid is equal to the mass of the full beaker minus the mass of the empty. So in this case, 120 grams minus 80 grams. That's how you could figure out the mass of a liquid. Now, if we're doing density calculations, that's great, because maybe you could also use that same beaker to measure the volume. And so if the volume ends up being, 60 milliliters, now you've got a volume of 60 milliliters, and you have a mass of 120 minus 80 is 40 grams. And I can use those two values to say, well, the density of this liquid must be 40 grams divided by 60 milliliters. And I've got about 0.67 grams per milliliter as my density. Well, that's great. I feel good about that, okay? This could be an experimental process. And I'm going to give you guys the equipment to do this. The next thing that we could talk about is, what if I want to know the volume of a solid? A really easy way to find the volume of a solid is to take a graduated cylinder full of liquid, and if I take that solid and I put it into the graduated cylinder full of liquid, then you know that that solid, if it's more dense than the liquid, is going to sink. But as it sinks, it's going to rise up the water line, the fluid level. If I measure this volume, let's call this volume 1, and I measure this volume, volume 2, then the volume of the solid is equal to volume 2 minus volume 1. And so we could just say, okay, well, if that one ends up being, 75 milliliters, and this one ends up being 95 milliliters, then that would mean that this solid has a volume of 95 milliliters minus 75 milliliters. And that gives us 20 milliliters. Now, sometimes people don't like to have volumes of solids expressed as milliliters, but remember, a milliliter is equal to a centimeter cubed. So if it's your preference to write the volume of a solid as a centimeter cubed, that's totally fine. 20 milliliter solid is 20 centimeters cubed, okay? And then again, if we knew the mass of that solid, then we could calculate its density. And we could easily find the mass of that solid by coming back up here and taking that solid and putting it onto our electronic balance. Of course, we would zero it first. And if we found its mass to be 40 grams, now we've got a situation where we can calculate D is equal to M over V. And we've got a 40 divided by a 20. And we could say, okay, well, that would mean that it's 2 grams per centimeter cubed. Now, that's probably not a realistic one for something that's going to sink in water. I'm just making up numbers, but hopefully the process makes sense. Does that feel good to everybody? I think it's really procedural, because what you're seeing on paper as you're doing math problems, maybe you don't have like a physical context for it, okay? So just in case that was like a visual that you needed, just wanted to put it